Have you ever stopped to wonder what's really going on in your brain when you're learning something new or when you're just laser focused on a problem? Well, it's actually a lot like a symphony, and it's conducted by just a few key chemicals. Today, we're going to pull back the curtain and see how three of these chemical conductors really shape the way we think and learn. So, let's dive in.
So, what is conducting that symphony inside your head? What's running the whole show? Let's get right into the neurochemistry of our own cognition and meet the tiny molecules that are fine-tuning everything, from what motivates us to what helps us focus. All right, before we can meet our chemical conductors, we first need to get to know the concert hall where they perform. And for us, that's the prefrontal cortex. This is the part of your brain where all the most complex, high-level thinking happens. I want you to think of the prefrontal cortex, or the PFC, as the CEO of your brain. Seriously. It's the executive suite, the command center, that's responsible for making all the big decisions, for planning ahead, and for pretty much steering the entire operation. And believe me, this CEO has a ton on its plate. The PFC is constantly juggling your working memory. You know, that mental sticky note you use for information you need right now. It's guiding you through tough decisions, it's piecing together everything you see and hear, and it's using what we call top-down control to keep you focused and stop you from getting distracted. It's a massive job. But no CEO works totally alone, right? They rely on a team of expert managers to help modulate everything. And for the PFC, that team is our three chemical conductors, a really special class of neurotransmitters called monoamines. So what are monoamines? Well, think of them as the brain's master regulators. They're not just simple on or off switches. Instead, they're more like dimmer switches for entire networks of neurons. They fine-tune the brain's overall state to meet whatever challenge is in front of you, whether that's focusing, learning, or adapting to something completely new.
And get this, they travel a long way to do their job. Dopamine, serotonin, and norepinephrine all start out deep inside the brainstem in these ancient, fundamental areas. From there, they send these long, branching pathways all the way up to the modern, super sophisticated PFC. This is like a critical communication highway, linking our brain's most basic reward and arousal centers directly to its CEO.
Okay, let's kick things off with the most famous of the three, dopamine. Now, I know it gets all the press for being the pleasure chemical, but its real job is so much more interesting than that. Let's think of it as the motivator. This is so cool. It shows us how dopamine teaches us using something called reward prediction error. So at first, an unexpected reward, say a piece of food, causes a big spike in dopamine. But as your brain starts to connect a cue, like a flashing light, with that reward, something amazing happens. The dopamine spike actually shifts. It stops firing for the reward itself and starts firing for the cue that predicts the reward. So you see, dopamine isn't really about pleasure, it's about the anticipation of pleasure. It's this powerful signal that basically says, hey, pay attention, do that again. But here's the catch, and this is maybe the most important part. With dopamine, more is definitely not better. The PFC, our brain's CEO, needs the amount of dopamine to be, well, just right. It's an incredibly delicate balance. And this is what scientists call the inverted U effect. It's pretty straightforward. If you have too little dopamine, your cognitive performance is low. As the levels rise into that perfect optimal range, your performance peaks. But if the dopamine levels get too high, your performance plummets right back down. So the goal isn't to flood your brain with dopamine, it's all about hitting that sweet spot for peak mental function. Okay, so dopamine is our motivator. Now let's bring in the other two conductors in our symphony, who play totally different but just as vital roles as the regulators. First up, we have serotonin, and we can call it the adapter. This chemical is all about cognitive flexibility, your ability to switch gears when things change, when the rules of the game are different. Then we have norepinephrine, the energizer. This is your focus chemical. It dials in your attention and arousal. If you've ever felt totally in the zone, you've got norepinephrine to thank for that. Okay, now this is where it gets really mind-bending. The very same chemical can have completely opposite effects depending on which little molecular docking station, or receptor, it latches onto in the brain. Just look at this. If you use a substance that blocks a serotonin receptor, it can do wildly different things. Blocking one type actually makes it harder for you to adapt and learn, but blocking another type can improve it. It's just a stunning example of how incredibly precise our brain chemistry is. So we've met our motivator, our adapter, and our energizer. Now let's bring them all back on stage together and see how they create the final performance, our ability to think, learn, and function.
Because that's the real secret, you know? Peak mental performance isn't about jacking up any single one of these chemicals. It's about the coordinated, dynamic, perfectly balanced dance between all three of them. They're constantly talking to each other, influencing each other inside our prefrontal cortex.
You can kind of think of this chart as the perfect recipe for your brain to work at its best. You need just the right amount of dopamine to drive your motivation. You need serotonin to give you the flexibility to adapt when things don't go as planned. And you need norepinephrine to sharpen your focus. When all three are in harmony, that's when your brain is really singing.
So, what's the big takeaway from all this? It's that your mind's highest functions, your ability to learn, focus, and adapt, aren't just random. They are conducted by this beautiful, delicate chemical symphony. Dopamine is what drives you forward, serotonin is what lets you pivot, and norepinephrine is what keeps you sharp. And the most important part of all, the secret to peak performance is their perfect, harmonious balance.
And that leaves us with one final, fascinating question to chew on. If our moment-to-moment ability to think and learn is really just a symphony of chemicals, then who or what is the composer? Thanks for joining me.